Hello everyone, I am Mandira Bera and I have completed this project under Pregrade's Artificial Intelligence and Machine Learning course mentored by Saurabh Kapil sir. My experience with Pregrade and Saurabh Kapil sir was extremely valuable. This course was very well structured and practical. It's not only strengthened my fundamentals but also gave me real project exposure that boosted my confidence in AI learning.
Let's start by introducing the purpose of this project. This project builds a loan detection model that helps predict whether a loan application will be approved based on various applicant features. To begin, I import essential Python libraries like NumPy for numerical operations, Pandas for data handling, Matplotlib, and C1 for data visualization, and also set up warnings to be ignored for cleaner outputs. Next, I load our dataset using pandas and display the dataset so we can understand its structure. This is done using the read CSV function, and the printed data gives us look at the raw records. Then I perform basic exploratory data analysis to understand our dataset better. Printing the shape shows how many records and features are there. Printing columns help us list all the available variables. Info function gives us a summary of data types and missing values. Describe function summarizes statistics like mean, median, and standard deviation for each feature. Okay. Now we check if our target class loan status level is balanced using value bounds function and proportion calculations. This helps us identify if our model will need special handling for class imbalance. Next, I check for missing values in each column using isNull function .sum and display their percentages. For any column with missing data, I show both the mean and median and visualize the distribution using C1 displot. If there is no missing data, I confirm that too. Now, to avoid data leaks, we check for duplicate rows using duplicated dot sum function and print any duplicates found. We remove them using drop duplicates. This ensures that training data is clean. Next, we visualize outliers using box plot for all columns. and also individually if requested. You can see here there is no missing data right now. Now here I have requested that if you want to see every column's box float, you can put here yes. I have put no so that I can proceed further. Since the data is highly skewed, I use percentile capping for outlier handling rather than the traditional IQR. This method adjusts extreme values but retains all data points, which is crucial for sensitive domains like loans. Here I have used IQR, and now for features like age, campaign, and previous percentiles are used to set lower and upper bounds. For binary columns, I clip values to 0 and 1. I print the new bounds and confirm modifications in data, ensuring data characteristics are preserved for correct modeling. Now, feature selection. I analyze feature correlations using Panda score function and visualize this with a Seaborn heat map. This shows how each feature is related to our target, highlighting important variables to focus on. I adjust axis labels for readability in the plot. Now, defining the features and target. I separate features and target. Printing these provides transparency on what data goes into the model and what is being predicted. Now, now we do feature scaling. Feature scaling is done using sklearn standard scaler. It normalizes the data, ensuring all features contribute equally to model training. I print the scaled results for verification. Now, model scaling. I compare multiple models: logistic regression, decision tree, AdaBoost, random forest, classifier. For each, I fit the model on scaled training data, then print their training test accuracy to compare performance and avoid overfitting. Here you can see every training and test accuracy. Here you can see logistic regression, training and test accuracy, decision tree, uh, training and test accuracy, AdaBoost, training and test accuracy, random forest. Then, then we use model prediction. I use the random forest model for prediction as it usually performs best. I predict on both the training and test sets and print some sample output to check result visually. Model evaluation. Model performance is further analyzed using a confusion matrix, Hurricane's confusion matrix, which I visualize using a heat map to highlight correct and incorrect predictions. I also print the overall accuracy and a detailed classification report for deeper insight into precision, recall, and F1 score, making sample predictions. Like I have a sample test here. I create sample input vectors and scale them, then use the model to predict the load and status probability. This demonstrates how the system works with new applicant data. I explain what class probabilities mean, showing the confidence of our predictions. Let's now see the whole project again. This is a box plot for every column. Now, it wants you to know that if you want every column's box plot or not. I am putting no. Yeah, then it shows this heat map. Now it's the next heat map I can see. And yes, it's finished.